Myself, Dr. K. Viswanath, Institute of Aeronautical Engineering, Dundigal, Hyderabad. Today we are going to learn the displacement, velocity and acceleration diagrams when the follower moves with simple harmonic motion and its derivation. So it is there are different types of followers we have studied before, and the types of followers are knife edge follower and flat faced follower and roller followers. Here generally many people, if you want to understand the camshaft, what is the purpose of the camshaft? The purpose of camshaft is here, you can understand. This is the cams, this is the shaft, this is camshaft. The camshaft consists of 1, 2, 3, 4, 5. These are 5 cams we can see here. Each 2 cams are connected to one cylinder. 2 cams are, each cam is connected to one valve. So one is acting as a open, that is a inlet valve, another one is exhaust valve. So each cam is connected to one valve. How it is helping to opening and closing of the valves we can see. So the cams is nothing but a oval type of disc is used for controlling the inlet and exhaust valves of an IC engine. An IC engine, that is internal combustion engine. So these are the purpose. Now here we can see there are different types of cylinders. It is a multi-cylinder engine. Each cylinder consists of 2 valves and each valve is operated with 1 cam, and all the cams are fixed on a shaft. That shaft is known as camshaft. Now we can see the working of how it is for 2-cylinder engine, the radial engine, how it is, V engine, it is happening. You can see V cylinders. So this is the camshaft, and on the camshaft there are the cams are there. The cams are in touch with these are the rocker arms, rods. These rods are connected in such a way that it is helping to control the inlet and exhaust valves. So we can see further, it is a 4-cylinder engine, and 4-cylinder engine, how the valves are being opened and closed with the help of a camshaft is connected. The camshaft is connected. Here there are 2 types of camshafts are there. Here we can see here. This is the one camshaft and rear one. This is another camshaft. These 2 camshafts are connected with the help of the gears, and these gears are connected with the help of a chain drive through the crankshaft. So on the crank, this is crankshaft, and it is camshaft. So this camshaft and crankshaft, it is a complete mechanism is important in order to run the machine, run the engines. Now there is a follower, any type of followers, as we have studied different types of follower, that is knife edge follower, knife edge, and roller follower. Third one is flat face follower or flat faced follower. This knife edge follower, roller follower and flat faced follower having different types of motions during outstroke and return stroke, or the valve opening and closing. So if the follower is, there are different types of motions are there. The types of motions, number 1, uniform velocity. Second one is simple harmonic motion, and the third one is uniform acceleration, and retardation, uniform acceleration and retardation. These are the types of motions. So when the crank is opening, here there are two types of terminologies. The valve will remains open for a particular rotation of a cam, and the valve remains closed for a particular rotation of the cam. These terminologies are in relation to the cam. There are another terminologies are there. In relation to the engine. So during outstroke or during suction stroke, so the outstroke and return stroke. The outstroke means it is completely going away from that. That is called suction stroke. The return stroking means approaching towards the valves. That is a return stroke. So the suction stroke and compression strokes are used by the terms known as outstroke and return strokes. During outstroke, the angle of rotation of the cam, that is so and so angle. During return stroke, the angle of rotation of cam is so and so angle. And between outstroke and return stroke, there is a dwell position. At that position, at that very small portion of the angle of rotation, that is 30 degrees or 60 degrees, the valve remains, or the camshaft remains, the valve remains the same position. But the point is that everything takes place in very small period of time. It is not like suction stroke, waiting for some time, and return stroke, again some more time, and dwelling time or relaxing. It's not like that. Everything takes place in less than seconds. It takes with the speed. Okay. Now we are going to study here if the follower, whatever type of follower may be, it may be knife edge follower, roller follower, or flat faced follower, is operated with or having motion of simple harmonic, then such type of motion of the follower, how to draw a displacement diagram and the velocity diagram and the acceleration diagrams by calculating the equations. What is the velocity, what is the accelerations, and these velocity, acceleration and displacement diagrams are in relation to the angle of rotation of cam. The angle of rotation of the cam is in terms of degrees. Here we are going to show here. What is the displacement diagram? The displacement diagram is the diagram of the lift of the follower versus the angle of rotation of the cam. The lift of the follower is a dependent parameter and the angle of rotation of the cam is independent parameters. That's why this angle of rotation of the cams are considered on the axis X, and the dependent parameters, that is lift of the follower, is considered on axis Y. And drawing the diagram between the lift of the follower versus the angle of rotation of the cam is known as a displacement diagram. Okay. Now with that, why we have drawn this semicircle? What is the consideration? Why we draw the horizontal circles? Why we have to draw the vertical circles? Okay. The important concept. What is the reason behind? What is the principle behind? In this diagram, we are going to learn in detail. Now, what is simple harmonic motion? That one has to know it. The simple harmonic motion means when the particle is moving circularly with an angular velocity. Suppose if the particle P is moving with uniform angular velocity omega, the projection of the particle on the vertical axis is P dash. When the particle moves in circular direction, the projection of particle P falls on vertical axis Y. the motion of the particle P dash is same as the motion of the follower, then that follower is under simple harmonic motion. That is a concept. With an angular displacement theta, okay, then the shade will fall, that is this OP cos theta, that is OP dash equal to OP cos theta. This P dash moves in vertical direction, okay, having that motion is called a simple harmonic motion. If we draw with respect to the time versus this displacement graph, that is x versus time, that gives the sinusoidal curve. That simple harmonic motion of the curve is the simple harmonic, that is in terms of sine and cosine, sine theta and cos theta. So that's say the motion of the particle P dash is in matched with the motion of the follower, then that motion is simple harmonic motion. Now, suppose we are considering here motion of a point. This, what is that? S, where S is the stroke of the follower, that is the displacement. What is the stroke of the follower? The stroke of the follower is the maximum distance traveled by the follower during the rotation of a cam. During outstroke, the maximum displacement takes place, upwards motion, and return stroke, it comes back. The maximum distance moved up and coming back, that distance traveled by the follower is known as the stroke of the follower. The stroke of the follower is denoted by the letter S. The units of the stroke of the follower is millimeter or centimeters or meters. Next, the terms theta R, theta O and theta R. O refers to outstroke, R refers to return stroke. So theta O means angle of displacement, angular displacement of the cam during outstroke, that is theta O. And angular displacement of the cam during return stroke, that is theta R. This theta O and theta R are related to the cam, but there is an effect. The effect is that when cam is rotating particular angle, that is theta O angle, the follower moves up. That means rising takes place. After that, what will happen? Then theta R situation comes. Then it is under theta R zone. Immediately the follower moves back down. So this theta O and theta R is important. Between, if the follower doesn't move neither upwards nor downwards, but particular angle of rotation of the cam. That angle of rotation of the cam is known as dwell. Next, what is omega? The omega is denoted, refers to the angular velocity of the cam in radians per second. Now, this theta O and theta R, what are the units of theta O and theta R? It is in radians while calculation, but the angle of rotation here, it is in terms of in degrees of the cam rotation while drawing on the displacement diagram. Now, the time required for the outstroke of the follower, we are considering outstroke first, next return stroke calculation. During outstroke, what is the displacement, what is the velocity, what is the acceleration of the follower. Now we are considering the outstroke position. Now time required for outstroke of the follower in seconds, that is TO equal to theta naught, theta O by omega. This is in radians, that is radians per second. Then it is dimensional homogeneity, the T naught in second. The units T naught equal to theta naught by omega. How much angular of cam rotation for a particular angular velocity. That is known as the time required for outstroke. Now, it depends upon the outstroke time takes more or return stroke time takes more. Which one? It depends upon the angle of outstroke and the angle of return stroke. If the angle of outstroke is larger, because here we are considering omega remains the same, constant. So under the constant value of omega, when theta O is larger than theta R, then definitely the time taking during outstroke is more than time taking during return stroke. Now that is theta naught equal to, that is time is required for the outstroke of the follower in seconds equal to theta naught by omega. Now from this circle, to understand the concept of simple harmonic motion, consider a point P moving at a uniform speed omega p. It is the point P having a angular uniform speed, that means angular velocity, uniform angular velocity, that is omega p radians per second, round the circumference of a circle with the stroke s as a diameter. If the stroke s has a diameter, then s by 2 is the radius. S by 2 radius becomes. Now the point P dash. What is the point P dash? This point P dash is the projection of point P on the diameter. This P dash executes simple harmonic motion as the point P rotates. That motion is known as simple harmonic motion. When point P is rotating in circular direction, the projection of with uniform speed, that is omega p radians per second, the projection of this point P either on y-axis or x-axis, the motion of having that projection of point P motion is known as simple harmonic motion. Why it is simple harmonic motion? That the projection of point P having uniformly moves, having uniform speed, that shade gives going towards either it is on y-axis, axis y, moves up and down with the center. That line, if it is moving on up and down motion, this axis is known as equilibrium position or mean position line, mean line. So this mean line, it moves up and down. So with the time it passes, if you draw that curve, it comes as sinusoidal curve. Or okay, that's why in terms of sine or cosine. So the motion of the follower, if the motion of the follower is similar to the motion of the point P dash, then that follower is having simple harmonic motion. Now here this point P, very important concept, from this circle comes. Yes. Now I am going to draw a displacement diagram from this concept. Okay. I am taking, even though when the point P moves 180 degree, then the projection takes place one time on x-axis. If it is moving P from this position to, from x to, you can make it x dash to, or from negative y to positive y, plus y. Then the P dash moves from O to plus y and y to y dash, it comes down. When P moves from negative y to positive y, this P dash moves from y dash to plus y, up and down. So what I am considering is that I am considering this up portion. What is this length? The length is called stroke of the follower on y-axis, and this semicircle is how much? S by 2 radius. Now what is the angle of rotation of the cam? The angle of rotation of the cam, outstroke and return stroke, consider and dwell angles also. Take on x-axis. How we consider? If theta O equal to 120 degrees, take a scale, and theta OD, dwell next to outstroke, is 60 degrees, and theta return equal to 120 degrees, and remaining thing, that is 180, then it becomes 60 degrees. Take a scale on x-axis, that is 20 degrees equal to 1 centimeter. Then theta O becomes 6 centimeters, theta OD 3 centimeters, theta R 6 centimeters, theta RD 3 centimeters. Draw a x-axis line by taking that scale. So the length of this scale is 18 centimeters. Then divide this portion into theta O, that is 6 centimeters, theta OD, that 120 degrees means theta O becomes, by using this scale, 6 centimeters. Theta return, theta RD. Now with this, join the curve. Now these are the portions, draw a vertical lines. Divide this theta O into equal even number of parts, that is 6 parts. Why we are drawing vertical lines? These vertical lines are diameter lines of the motion of what? The motion of projection of point P. That is P dash path is vertical lines. These vertical lines denotes the path of follower. These vertical lines denotes the path of P dash. Now, after drawing these vertical lines, now this is the vertical line, minus y to plus y. These are the vertical lines. Now this is the semicircle. The point P dash, the point P having angular motion. So divide into equal number of parts, even number of parts, that is 0, 1, 2, 3, 4, 5, 6. The path of projection. Now I am considering this P point. What is the path of projection on P point? Where it will projecting? It is projecting on vertical line. Here it is projecting on diameter line. That diameterless line is y axis y line. Now these are the axis y lines. When the point P 0, 1, suppose it is P1, P2, P3, P4, P5. Alright. When P1, 1, 2, 3, 4, 5, 6. When P1 projection is on 1. When P2 projection will be in which line? Because it is moving. It is 20 degree. When it is 20 degree of angle of rotation of the path of point P1, that at that time the cam is rotating up to which position? This is 1. 0, 1, this is 120 degree, divided into 6 equal parts. That means each part indicates 20 degree. Next, part 2, that is 20 plus 20, 40. This is 60 and so on. Now, when the cam is with 20 degree of rotation, the harmonic motion moves from 0 to P1, that is 20 degree angular displacement. That projection falls on 1. Next, P2 is 40 degrees. At that time, where it should fall? That projection of the point P2 on the 40 degree of cam rotation. What is the 40 degree of cam rotation? That is the second vertical line. Now, third vertical line, that is 60. Okay, 3, each 30 degrees. Okay, that is divided into. Now, that is 90 degrees. So, each motion, it represents completely, it completes how much? 120 degree of cam rotation. But the simple harmonic motion, this circle is how much? The 6 r, this is 180 degree. But that 180 degree, the length, the diameter is that stroke of the follower. So the stroke of the follower, how many number of parts you have to divide? Whatever the number of parts, we divide even number of parts, the outstroke of the follower, same number of parts, this simple harmonic circle, this SHM circle should be divided. That's why this is 6 parts and 6. Now it is 20 degree, don't divide into 20 because it becomes 20, 180 means 9 parts. So, but the length of the travel of the point, this P dash projection is stroke of the follower, that should be equal. So, that's why this 30 degrees, that is 6 division moves, that's the 6 divisions of projections on vertical lines. Why we are drawing or horizontal lines? These horizontal lines are projection of the path of the point P. That's P1, P2, P3. That projections, when it is moving in circular direction, the projection of the point P on a vertical line, the motion of those projections is having simple harmonic motion. That's why in displacement diagram, we'll draw, this is the curve. This is the simple harmonic curve. So similarly, outstroke or return stroke also, we have to complete the portion of the return stroke with the same projecting, the same projection point on these lines. Alright. Now, Why we have to draw semicircle while drawing the projection lines? Here the semicircle, you can see why we have drawn semicircle. Why should we do it? It is not semicircle. During of one semicircle, the projection of the point P moves from down to up. Rising takes place during outstroke. The same circle, it moves. It's the same path. But then it becomes what? Return stroke. So the coming same path taken by same points, no? That's why the same projection of the points here will project you onto the return stroke. Okay. But generally, it should be a complete circle. Then you draw projection of the points. So when it moves, but the point is that when it takes one turn, that means during rising takes place, one semicircle traveling of the point P, rising takes place. When it is return, again returning takes place. That is called return stroke. So outstroke and return stroke. Now how to find out the displacement, okay, and velocity and acceleration? We know the concept of engine mechanics. If we know the displacement S, then what is the velocity? ds by dt. What is acceleration? F equal to dv by dt or d square s by dt square. That concept we use here in order to calculate the velocity acceleration of the body of the follower when it is under simple harmonic motion. Now it is the value. What is that meaning? The displacement, that is time required for the outstroke of the follower in seconds, that is t naught equal to theta naught by omega. Now after knowing that, we need velocity. What is the velocity equal to? Displacement by time. What is the displacement by time? The displacement is called pi by 2s. That is the angular. How it comes? Very simple. The angular displacement, that equal to concept of this formula comes from where? We know that suppose theta and it is r. What is the L equal to? What is the length of the arc? L equal to r theta. Okay. Similarly, we are going to use here r theta, that is length. Length by time, that is the velocity, meters per second. R theta by time t naught. What is that r here? The r is radius of the follower, that is s by 2. R equal to what? Radius of the follower. Total is s. R equal to s by 2. What is the theta? The theta is 180 degrees. That is radians. So pi by 2 s by t naught. What is the t naught here? Time taken. Substitute here pi s by 2 by t naught, that is theta naught by omega. That is the concept. So this is the 6th class mathematics. From that concept, 6th standard mathematics, where length of arc equal to r times theta, radians. Now here that from that Vp equal to L equal to L by time, meter per second. What is the meter? L, that is pi by 2 times pi into s by 2 times by t naught. Now pi s by 2, what is the t naught? Just now we studied t naught equal to theta o by omega. Substitute over here theta o by omega. It comes to, for simplification, that pi by 2 s times omega by theta naught. Very simple. If you know, that is the peripheral speed of the point P dash. Peripheral speed of the point P, that is simple harmonic velocity, that is Vp. So the maximum velocity of the follower during the outstroke equal to V naught equal to Vp, that equal to pi s by 2, pi by 2 times s omega by theta naught, that is pi omega s by 2 theta o, outstroke. Now what is the acceleration? The acceleration equal to, it is v square by r. That is v square by r. What is that v here? That is v0. That is vp square. What is that r? op. Now that r equal to s by 2. Now pi omega s by 2 theta naught whole square by s by 2. It comes to side, then 2 by s. That pi square omega square s by 2 theta naught square. Now that is the maximum centripetal acceleration. Now maximum acceleration, the centripetal acceleration is nothing but the maximum acceleration of the follower during outstroke. Now if you want return stroke, what is the return stroke? We are equal to substitute in the place of outstroke angle, we have to replace with return stroke angle, 2 times return. Now AR equal to pi square omega square S by 2 times theta r square. These are the formulas for velocity and acceleration during return strokes. Pi omega S by 2 theta r, and acceleration of the follower and the return stroke, that is pi square omega square S by 2 theta r square. Now these are the terminologies and these are the equations we calculated. These are velocity, displacement, velocity and acceleration of not the cam, of the follower. Very, very important. Whatever follower may be, if the follower is having a particular, that is simple harmonic motion, these are the equations are applicable in order to calculate the velocity and acceleration during outstroke and return strokes. One more important, how to draw those graphs in relation to by using these equations during outstroke and return strokes. So the velocity graph looks, velocity with respect to the graph, the velocity diagram is the diagram of velocity with respect to what? Angle of rotation of the cam. This is the shape of the equation during outstroke, the shape of the curves, velocity curve. These curves are what? It is only for simple harmonic motion case study. If it is uniform velocity and uniform acceleration, retardation, the curves will be changed. Now it is the maximum V0 and the maximum during return stroke, the sine curve. These are the sine curves, simple harmonic motion. Now acceleration diagram, how the curve shapes comes. If you draw the acceleration with respect to the angle of rotation, if you substitute the values, these curves will be changed from positive to negative and negative to positive. So the maximum value in this curve, that is the maximum. So what is the minimum? That is the 0. What is the negative cosine curve here? These are the cosine curves, the maximum. Sine curves are observed in velocity diagram and cosine curves are observed in acceleration diagram. Very important. And one more thing is that how to find out here. Here, if you understand, the stroke of the follower remains constant. It is uniform velocity. So all are constant. What is the variable here? V naught is variable, is theta naught is the variable. If the angle of outstroke is changing, then velocity will be changed, the velocity curve. Similarly, if you apply the concept, pi omega square S by 2, they are constant. But what is the variable here? Outstroke is variable. So it is the AP angular velocity, that acceleration of the point P during outstroke and return strokes gives cosine curves and the velocity curve gives sine curves. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.